Okay, good evening everybody. Thank you all for coming here in person and thank you for making it on time. That's great, so we can start on time. Hello everybody on YouTube as well. Thank you for joining us, and this evening we have an interesting gem jamming session. We are going to be talking about new technologies in jewelry that are used not for, digital jewelry production, which is what people typically think of when they think of new technologies, but these are new technologies that can be used by craftspeople, by creative people to use their hands to be able to make things that, a few years ago, a few decades ago, were simply not possible. And this has to do with the advent of powder metallurgy, the science of powdered metals. And we're very excited to share with you more about this particular technology today. Now, this is one of the sessions that is run by both myself and Tanja Sadow. Tanja is the founder of the Jewelry Design and Management International School. And Tanja has 40 years of experience working with every aspect, every facet of the jewelry industry, from retail to wholesale to design to manufacturing. And in fact, Tanja has been teaching people how to use this particular new technology since the 1990s?
Yes.
So we've had a lot of experience working with this particular kind of technology, and it's a very exciting way to be able to manipulate metals and create some beautiful pieces. Now, before we get into the actual presentation itself, I wanted to share with you just a 2-minute video to tell you who we are here at JDMIS. We are the only school in Singapore that specializes in jewelry. Rather than have me talk about it, I thought it might be more interesting to play a short video for you. So here we go.
Since 2007, the Jewelry Design and Management International School has given thousands of people the confidence to create quality jewelry. Established in Singapore, in the heart of Southeast Asia, JDMIS has conducted courses for some of the world's most distinguished jewelry companies, as well as passionate amateurs and those ready for a career in the jewelry industry. Specializing in the jewelry arts, JDMIS provides exceptional education in jewelry design, fabrication, gemology, and business. The tools that students receive from JDMIS on their first day have traveled with many along the road of jewelry making success. Tanja Sadow, founder of the JDMIS, is an award-winning jewelry designer and renowned jewelry educator with over 30 years of experience training the jewelry industry. Tanja, with her team of expert jewelry artists and instructors, created the JDMIS curriculum to be comprehensive yet flexible. Small class sizes, personalized attention, and an unmatched support network ensure that each participant leaves with the knowledge, skill, and confidence to succeed in the jewelry industry. Designed for the jewelry trade, training at JDMIS is fast-paced and packed with useful practical information. But with a diverse range of participants, courses are also great fun. Learning at their own pace, participants study the latest information about gemstones and jewelry styles. They gain confidence using the best of traditional and contemporary techniques and learn how to apply each of these skills to their businesses. All JDMIS courses are completely modular, and they can be taken individually. For each skill they learn, students receive a certificate and can combine these skills to receive a comprehensive diploma qualification. Graduates in more than 42 countries delight friends and relatives with their unique creations. Many graduates showcase their pieces online, and JDMIS's brightest stars operate their own successful retail jewelry businesses, designing and producing exquisite jewelry that enchants their customers. The possibilities are endless. What will you create?
Fantastic. So let me just say welcome to everybody, and welcome to everyone on YouTube. Now, I've been asked to sit very carefully on this chair because I apparently move too much and move my hands too much for the camera. So I will try to stay very still here and explain to you about this wonderful product, which is really exciting. I find it exciting because, quite frankly, when I started back in 1980, this did not exist. Yes, so when we learned how to make jewelry, we had to do it the traditional way. There was only one way to do it, and that was to take the metal and to hammer and to bend and to solder, and that was it. And it was the same thing that we had been doing since 5000 BCE, which is amazing. And this is something that has come about because a great deal of metals, especially precious metals, are recycled. And today recycling, of course, is more important than it has ever been before. So we're happy to say this is a green product. This is something that that people can be proud to use because it comes from recycled metals as well. Typically, silver can be recycled from, as you can see over there, X-rays. A lot of X-rays are just burnt, and when you hold an X-ray up to the light and the part you can't see through, that's the silver inside the X-ray there. And then, of course, gold. Tons of gold comes from all kinds of places. I mean, when I say tons, it comes from inside computer chips. It comes from even old teeth. People have gold teeth. We can melt gold teeth down. Do you know that 85% of the jewelry we wear today is recycled gold? That's because we're not really extracting it so quickly from the earth, and it's very difficult to extract it from the earth. So there is a great deal that is recycled today. So when they were doing the recycling process, what they discovered is that they were finding this kind of a powdery metal that was collecting on the anodes or on the cathodes. And what was happening was that if they scraped it off and then they crushed it down into a very fine powder, they thought that it would be interesting to see what they could develop. And this was back in the early 80s that they were experimenting with it. And they crushed it down to a very, very fine powder. As you can see here, this is super fine. In fact, if you look, we're talking about nanometers here. So they're very, very tiny. About 200 particles of silver, equivalent to 1 grain of table salt. So that's how fine it is. It feels like baby powder. It feels like a very, very fine powder. And then what they do, they add an organic binder and they add some water to it. And by adding that together, the water makes it soft and malleable, like Play-Doh or some kind of putty, and the organic binder holds it together. So we end up with a lump of material that is metal. It's completely metal, but it's soft, and you can mold it and form it like Play-Doh. Now you would say that, okay, but how do I get that to convert into solid metal? Because that's what we want. We want it to be solid so that we can wear it. So basically, while it's in its kind of soft state, we can roll it, we can pull it, we can make it into whatever shape we want. Then what we do with it, we can dry it. Now when we dry it, the effect is that it makes the piece become hard, like a piece of wood, not hard as metal. But when it's hard as wood, this has another benefit, and that benefit is it's very easy to file, or it's very easy to carve. Now, I don't know if you've ever tried filing metal. I know some of you have. This is 20 times easier to file and 20 times faster to get to your goal than filing metal. Yes, 20 times. And of course, that means that when we are carving it, it makes it very easy to carve. So rather than carving metal, we normally carve waxes. And when we carve waxes, then we still have to convert the wax into the metal through the lost wax casting process. This way, we can totally bypass the lost wax casting process. We don't need to go and find the person that's got the casting equipment, and we don't need to leave our design with them to do the casting at the risk of somebody, well, copying the design, which is absolutely possible. So it becomes hard. We file it so that we can make the edges nice and crisp, and we can make the shapes that we want. And then after making sure that it's completely dry, what we can do is we can fire it. Now there are typically 3 ways of firing. You could buy a kiln, which is an expensive piece of equipment, and a lot of people think, oh yes, if I have to buy a kiln, oh, it's going to cost $1,000. Actually, yes, today we can get kilns that are cheaper, which will work. But we don't have to buy an expensive piece of equipment. You can do it with a gas stove. Why? Because the silver does not require a very high temperature to fuse. In fact, these torches here, the little handheld torches, they can go up easily to about 1,300 degrees. And that is sufficient to burn off all the organic binder and to burn off the water and make sure that the metal sinters together, which means it fuses together. Every little particle fuses together. So you see the little circle, and inside the circle we have only left the silver, and all the water in the binder burn off in the process, and the sintering happens. It all comes together like fusing. That's what sintering is. It's when all the little particles fuse one to another. So that's another method, and this is yet a third method. You can put it on your gas stove at home, and I think pretty much everyone's got a gas stove probably. If you don't have a gas stove, we can buy a little gas stove for $20, $30 from Mohammed Mustafa. That's easy enough to do. And all you need is to put it onto a steel rack, and then you bring up the gas stove to the highest temperature, and again, what's going to happen? The organic binder, the water burn off, and all the metal sinters together. Once that happens, you have a solid metal item. You can knock it very hard on a surface. You will see it does not break, it does not shatter. It is just as strong as any piece of cast jewelry. Yes? How much mass do you lose? You have about, I think, 6%. Loss. 6%, or if it's in size-wise, if that's what you're asking, it can be anywhere from 10 to 15%, depending on which type it is. But it's not a lot. So let's put it this way: if you're making a ring, that percentage of shrinkage, you would feel it. So we know that it's going to be some shrinkage beforehand, and so what we do is we compensate for that shrinkage. So we'll make the ring a little bit bigger so that when it shrinks down, it's the right size. And we've already made 50,000 rings, so we know the size, we know exactly how to do that. If it's a pendant, then there's no reason to bother to do any adjustment at all, because with a pendant, that very small percentage, 8 to 10% or 15%, is really not going to be visible. So basically that's it. Yes?
We also had a question from Bella online.
Yes.
She was asking about what settings you would use for your gas stove. Do you put it on high? You put it on low? Is there any specific temperature?
So Bella, yes, what we do is we put it on full. I have only once ever heard of anybody melting their piece on a gas stove. Once. And that was a very special gas stove from Germany. It was some very special one that apparently goes to a very super high heat, higher than normal. So if you have a normal gas stove, the typical gas stove that everybody has at home, then you put it on the full heat and you don't have to worry. Because a gas stove normally goes up to about 760, maybe 780 degrees centigrade. The silver doesn't melt until 870 degrees centigrade. So there's a big buffer there, so we don't have to worry. We can cook it already and sinter. We can do that at about 650, which is the lowest that we can sinter it at. But if you're going to sinter it at the lowest temperature, then you should leave it for longer. So for example, if I'm doing it in a kiln, I might plan to do it at 800 degrees for 15-20 minutes. If I'm doing it with my torch is going to about 1,300 degrees. So I would be a little bit more hesitant, and I would only leave it for about 2 minutes with a torch. And that would sinter it perfectly well because of the heat. But if I'm doing it on my gas stove, then I would leave it for at least 10 minutes on the gas stove. So different temperatures, different timings, and I would definitely, Bella, use full on your gas stove. and leave it for 10 minutes. And when we say leave it for 10 minutes, that's the minimum we leave it for. If you leave it on the gas stove for 15 minutes or 20 minutes, nothing bad will happen. It's not going to overcook. It's not a piece of steak. It is just going to continue to sinter, and it'll sinter perfectly well. So it's not a problem. Okay, now once it is sintered, and that means once it's solid, you'll see that you can do absolutely everything to it that you can do to any other piece of jewelry. So if you wanted to brush it to give it a brushed finish or to remove a crystallization that forms through the process, then the steel brush is a very good one to use. If you wanted to set stones in it, you could. If you know how to set stones, then you can use the traditional stone setting techniques to set stones in it. Or if you don't know how to set stones in it, you can take it to a jeweler and say, I want you to set a stone in this. And he's going to be able to do it in a very normal way, because he's just going to do it the same way he would in any other silver. And then we can also burnish. Burnish is where we take a very hard steel burnishing tool and we rub it with the steel. And when you rub it with the steel tool, it just compresses all the little particles of silver and makes it very, very shiny. So if you want to add a beautiful shiny surface to it, then usually we would burnish it first before rubbing it with a polishing cloth. So basically, after sintering, it looks exactly like any other piece of metal. It is really no different. So I'm going to give you a quick demonstration with a video. It's just a very simple ring. This is something that can be done literally in 5 minutes. So I will show you this one. You can see how soft the material is. It's really soft, so we can roll it into a nice little snake-like form. And we do add a drop of water here and there because your fingers are warm. And if you're rubbing it with your fingers and you're rubbing it fast, then you're heating it up a little bit, and of course some of the water's evaporating. So if you want it to make the shape you want, then keep it moist. Now you can see it being wrapped around. This is a mandrel. We call this a mandrel. And it's a wooden mandrel because this one is not, it's just for support to get the right size of the ring. So we would have measured where on the mandrel we want to make the ring. Now, this has been dried. You can see we're filing it here. So when it's wet, it's soft. But then when you heat it up, when you start drying it with a hairdryer, then it becomes hard. So we take it off the mandrel once we've filed it and made the edges nice and straight. We take off the paper, and then we do a bit of cleanup. It's so much better to do the cleanup at this stage, because remember that it's 20 times easier to file now than it would be to file once it is fired. So every bit of cleanup we can do, we do it before firing. So there you see my torch. So in 2 minutes, I'm heating it up. You might see a tiny little flame. Do you see the flame? Very small flame. It doesn't go out in a big flame. And when the flame dies down, then it goes to a red hot. And as it is red hot, that's when you start the countdown for how many minutes, 2 minutes or 10 minutes or whatever it is. And here we did a 2-minute countdown. And once that's done, then basically you cool it. How can you cool it? Same as you cool any metal. You put it into a little bit of water, cold water, and after that you brush it with the brush, and then you can burnish it with the burnisher. Of course, you've got to brush it inside and out everywhere. You get the crystallization off, because there's usually a little kind of a powdery surface to it. And then the burnisher will also make it shine, and it'll press all of the little components together, those little particles of silver together. So we get a very nice finish. And it's easy, it's fun, it can be done at home. You don't need anyone to do anything, because you can do 100%, you can do everything by yourself. So for people who like to be artists and who like to make one-of-a-kind pieces, I mean, this is perfect. I wouldn't suggest that it's great if you're going to mass produce, because it's not a product which is made for mass production. It's a bit expensive for mass production. We can buy loose, grains of silver and stuff, which is much cheaper. You buy it by the ounce instead of buying it ready, prepared in this form here. When it is prepared in this form, it means that it will be a little bit more expensive. All right, so what else? So what can or should be made with this product? This is a very good question. A lot of people ask me that. Would I do everything with this product? No, I wouldn't do everything with this product. If you look at flat sheet metal that we can saw and pierce, like we do in our metalsmithing class, and we make these kinds of things, if you're going to add things like rings and it's just flat pieces that you're drilling holes in, then you might as well take sheet metal and wires and work with those, because it will be faster and easier to do. Like chain, for example. I definitely would never suggest that you make each little link and then, no, that doesn't make a lot of sense. So what should be made with this is sculptural designs. So if you look at, say, the horse over here, all right, how would you make that horse in a sheet of metal? You'd have to literally hammer, 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 or carve the metal. Carving the metal is disastrous, it's very hard. Filing it, you'd never get to file it to that point. You'd be wasting so much metal, right? So all these kinds of designs, which are very sculptural, would be made usually in the wax. And that's how we would have done it traditionally, and then we would have cast them. But today, we just mold it in the hand, we dry it, and then we can file it in the clay form where it's still a little bit soft before firing, and we can do amazing things. The other thing that's amazing, textures. It takes textures so beautifully. So I'll show you in a minute how you can do things that are with textures. Yes?
We had a couple of questions from the
Okay.
internet. Maybe it's a good time to ask them now.
Sure.
One of the questions was, is it safe to wear?
Absolutely. It's very, very safe. If you're working with the silver, it is 999 silver, right? That's one of the types. In fact, we're going to go through all the types in a minute, but we will do that. But it's pure silver, as pure as it can be. You can wear it in your ears. You will never have allergies. You will never have anything of that nature. It is very nice to wear, and it's good metal, very good metal, pure metal.
I can add something to that one. So typically, if you ever have come across somebody that says, I'm allergic to silver, what they're allergic to is not silver. In fact, if you go and look at all of the medical devices and things like that, you know, they use silver ions, they use silver in your medical, tools and things like that. That's not something that we can have a reaction to. The same goes for gold. Our bodies don't react to gold. What they react to is the other metals in the gold alloy or the silver alloy that's used. And so for most people, when they say that they have an allergy to silver, they're saying that they actually have an allergy to nickel that is alloyed with silver to make it a bit brighter and a bit harder. And that's the thing that their skin is reacting to. And because this is 99.9% silver, there is no other alloy. We can't say 100% because it's nearly impossible to get 100.00%. We go as close as we can, and basically it means it's pure silver. So there's no other metal in the alloy.
So again, there's the 999 variety, which you can see here is pure. We then later, much later, they came up with a 950, and then later they come up with a 925. So the 925 does have some other alloys in it, but all the alloys that they put in there are other metals, but they are not nickel. There is no nickel in this product at all, and there is nothing that would cause allergies. So absolutely, it's all very, very safe. So that's basically what this slide is telling you. Now, could you tell the difference between a 999 and a 950 and a 925? The truth is, you cannot see the difference. They all look the same. And even if we were to make them by traditional methods, the difference between 999 and 925, you can't see it. It's not obvious. The only way that we would know is to look for a stamp on the inside, and that stamp will tell us what the metal is. But otherwise, you cannot distinguish. And does that make a difference to going forward to having a jeweler set a stone or to doing anything else with it? No, it doesn't make any difference at all. It also comes in 22 karat gold and in 24 karat gold. Now, this one's 22 karat gold, and it's in ancient Egyptian hieroglyphics. And this one spells my name, Tanja. Yes, you can guess I made that one. And I actually made it just with my fingers pressing down to flatten it. You can still see my fingerprints on it, which makes it very personalized, which is kind of something I like. And then I took rubber stamps, which today we have plenty of rubber stamps, and just chop, 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 chop with the various ones that were for my name, and I was able to personalize that necklace. And this is a necklace I made already back in 1995, and I still have it and I still enjoy it. In fact, when you leave here today, if you go and look in the showcase, a lot of these pieces you will see they're in the showcase right here. So this one here is a copy of a very ancient piece of jewelry that was done by the Vikings back in about 1 or 2 AD. And this one is gold foil. So I made it in silver and then I put the gold foil on it. So when we do gold foiling, it comes in a very thin 24K gold, and we fuse it onto the top with heat. And there is a specific way to do it. Again, you can put it on a heating plate, and when the heat comes through the metal, it just fuses on at a certain temperature. And the other one also is a 24 karat gold. This is a solid piece of 22 karat gold, so it can also be combined together. This centerpiece is the 22 karat gold, and the bezel holding it in is the silver, and the rest of the ring is silver. So it's nice to be able to combine these things as well. And we can also get it in pure copper. The first one is a fish, pure copper. The second one is the bronze clay, and then we can also have brass, and we can also combine brass and copper together as well. So as far as creativity goes, we can really combine colors to be creative, which is great, and we can get some and it all works the same way. The difference is the firing. So when I fire gold, then I'm going to have the kiln to fire the gold, because you need to fire it at a much higher temperature. Gold fires at a higher temperature. Copper fires not quite as high as gold, but a little bit lower than gold. So a kiln is good to have with copper as well. But silver fires much lower. So that's why we don't need the kiln for that particular one. And what else? There are all kinds of types available. So the types are interesting in that the different types allow us to do very different things with great ease. So when we talk about the first type, which we like to call a lump, it literally comes in a lump. That's it. And then when we press it, we can mold it and shape it into whatever shape, and we can create amazing things. This was done by one of our students. It actually has a little hinge that opens and closes. It's amazing. All kinds of rings with beautiful sculptural feel to them. And you can create, if you like making small things, you can create small things and attach them all together. That's easy enough to do. And of course the rubber molds, if you buy rubber molds today to make the little things you put on cakes, those work beautifully for this as well. You just press the lump into it and it'll come out beautifully in the right shape with the textures and everything on it. So it makes it very, very easy. So that's the lump type, which is the first type, which most people start with. Then we have another type, which is a syringe type, which means that they have watered it down and they put it in a syringe and you can extrude it. So like you can extrude icing on a cake, you can extrude this stuff anywhere you like. And typically we have a material which is called cork clay, and the cork clay forms like a general form onto which we can put our syringe type. So inside this bead we would have had the shape of the cork clay. And the beauty of the cork clay is that the cork clay actually it disintegrates at a much lower temperature, at about 300 degrees centigrade. So when I have covered my cork clay with the syringe type of silver, let's say, then I make sure it's all dry, and then when I put it into the oven, or even if I fire it, the cork clay burns away completely, leaving me with a hollow object. So these beads right here, which are just syringed around and around and around and around, they are all hollow beads, which makes them very nice because you can do big, lightweight objects which are very, very wearable. So the syringe type is a really interesting type to have if you want hollow objects. And then we have another type which is called the paste type. Now the paste type, you can paint it onto a leaf. So it becomes so soft and so kind of wet that when you paint it onto the leaf and then dry it, you can create one solid layer on top of the leaf and then put another solid layer on top by painting a next layer and drying and painting a next layer and drying until you have a good thickness. And when you fire it, of course the leaf, which is an organic material, is just going to burn off. And as that leaf burns off, it leaves us with the beautiful imprint of the leaf. So that's what we do with the paste type, which is fantastic. You just paint it on. You can paint it onto paper as well. Yes?
This was a good question. Bella asked about repairs.
Yes.
And I thought that since you're talking about this, you might also talk about what happens if you make a mistake. Because it's possible that when you're doing something, it doesn't quite work. Maybe it breaks while you're making it. What can you do to repair it, and how does that work?
So, as an example, you can see here in the tweezer is a little tiny ring with a small post. So in order to put a piece of metal embedded into another piece of metal clay that we have made, then we drill a little hole, we fill the hole with the paste because the paste is very soft, and then we can go ahead and implant our piece of metal. And what's going to happen is when it dries, it grips on, and when it fires, it shrinks and grips it even tighter. All right? Now what happens if I had a ring on there and the ring broke off? Then I could do exactly the same thing. I would paste the ring back in place and it would become very solid. Or I would drill another hole, put another similar one down into the hole, and I would make sure that it is secure. So definitely paste is used for fixing. If I'm carving something, let's say I'm carving a little animal and somehow I carve off its nose and now I've lost its nose. It's not that, oh my gosh, now there's nothing we can do. If I had a raw metal and I carved off its nose, I'd have to start again with another piece of metal. I can't just add more metal to it. But with this, I can use my paste and I can build up and I can add and I can make the nose bigger and bigger or carve it down again very easily. So definitely any repairs can be done with the paste, and we can repair this stuff very easily before we fire it, and even after we fire it we can repair it. Yeah.
Ellie had a question.
Yes, I explained it?
Sorry, two disliked metals.
It's
two disliked metals. So
yes.
Silver, and if you're going to insert stainless steel.
Okay.
Would you be able to use a stainless steel ring?
The answer
and
is
have the silver clay.
yes.
Fused.
So I can. What we need to be careful with is how the temperature is going to affect the other metal, because we know that the temperature is not going to affect our metal other than to cause it to sinter, and when it comes out white and clean and beautiful. But if I were to heat up, say that this little thing here was not 999 silver, we can buy them in 999 silver. What if it was 925 silver and then I heat it up? All right, those of you who do metal smithing, you know that when you heat up a piece of 925 silver, the copper comes to the surface and then it turns black. So we get oxidization. And that would happen if that little piece was a 925, but my original piece is still going to be very clean. So could I put the thing in pickle to clean off the oxidization? Yes, I definitely can. Would it be better to buy the appropriate one, the 999, and put it together? Yes, it would be appropriate to buy the 999. Stainless steel, I don't think much will happen to it. I think you could probably heat it up. Yes.
So just to follow on from that, we had Claire asking about pickling the 925 material.
Yes.
So first of all, if you're using the 925 variation, do you still need to pickle it?
No, you don't need to pickle it at all because it never turns black. There's no reason to pickle it.
Why is
Pickling
that?
removes the black surface. When we heat up metals...
No, if you use the 925 variety, not the 999 variety.
I see. If you use a 925 variety, let me just think a minute how we do it. There is a way to prevent us from having to pickle. We do have ways to prevent the oxygen from getting to the actual silver. And so when we can cover it with a blanket, which is a special heat blanket. We can put it into carbon, a box which has carbon in it, which will prevent the oxidization getting to it. So I mean, those are different ways that we can prevent having to pickle, because some people don't want to pickle. Pickle is a material that is actually quite dangerous. It's got sulfuric acid, and it removes the oxidization from metals very quickly, but not everybody likes to have that in their home. So this is one way to do it without having to have dangerous chemicals in your home to work with this material.
Maybe I can also add a quick one there.
Yes.
So the 925 material,
Yes.
Although that does have other
Alloys.
metal alloys in it, there are variations that are very interesting that do not require pickling and also have some of the benefits of the 925. For example, the 950 material is stronger, but it also doesn't require pickling in the same way.
Right.
And there's another material that they call slow tarnish that has a, instead of mixing in copper, for example, they mix in germanium, which is a rare earth metal, and that adds a little bit of strength, but it also slows the material's speed of tarnishing, so you don't actually have to polish it up as quickly, and also naturally you don't need to pickle it. So there's quite a few interesting things in the variations of alloys that you can buy ready-made that don't require you to go through the process of firing, pickling, which is really troublesome. Great.
But the 9991 is really the best one to use because it's the purest and because we would never need to use pickle on it. Yes. Yes.
Because it's sintered.
Sintered?
Because it's sintered, how fine can you make a product?
Yes.
How small and fine can you mold?
Okay. Can I back up? Am I allowed to back up?
Yes, of course.
Okay. Let me just back up
Thank
a second.
you. I got it.
Okay, do you see the head?
Yes.
It's about that big. Do you see the ear on the head? Okay, so if we can do an ear that actually really does look like an ear, I mean, that's very fine detail there. We can really get to fine detail. The only thing that limits us with this is our eyesight. So if you can do it with magnification, if you can put not just reading glasses, but have some good optivisors that magnify to 10 power or something like that, you can get it really super small.
And is this handcrafted or is this out of a mold?
This is not a mold, this was carved. This was hand carved. I can tell you it was hand carved because I carved it myself.
So
Yes.
technically
They're carved.
the grain size is the limiting factor,
Yeah.
and it's 5 microns. So that's smaller than most machines would be able to produce for
Yes.
everyday manufacturing.
Now, here's a little caveat. The hair was not made with this product. The hair is stainless steel. So what we did, I made the head first, and then when it was fired, and I fired it with the stones in place. So those are sapphires that were in the eyes, and I fired the sapphires in place. And some stones can take the heat, some stones can't. So you have to be very careful when you're heating gemstones. But then afterwards, I drilled lots of holes in the head, and then I took the binding wire, which is a very, very fine wire, and I made it into little tufts, and I pushed it in so that the hair was coming out, and then I was able to arrange the hair. And actually, you can arrange the hair in all kinds of different ways. One day we can do it this way, another way we can do it that way. It's kind of a fun piece that you can play with as well. Yes. But you're not limited with size. You can make any size. It's not easy. You would have to have some practice, but I'm sure that you could actually go down to small sizes.
Since you're here,
Yes.
would you mind going back to the hieroglyph necklace? We had a question about cost. So we had a question, if somebody wanted to make a hieroglyph necklace like this has 5 letters.
Yes.
Do you have a sense for how many grams of gold this might have been?
This was 5 grams.
5 grams
Yeah,
of gold.
this was 5 grams.
So if you wanted to make a 9 element thing, you might be looking at
A very expensive
9 or 10 grams of gold.
Yes. The gold is not cheap. 3 grams of gold can be easily $300+ yeah.
Yeah.
So this was 5 grams. Yeah. So, but the thing is, if I went somewhere to have it made, what are the chances they would make it the way I want them to make it? And would it be very easy for them to do this? Well, there would be challenges in doing it, and we'd probably have to pay just $500 for the labor alone, and then pay for the gold on top of it. So I don't believe it would be cheaper, and these are not things that are mass produced. These are one-of-a-kind pieces anyway.
So just to talk about costs, because I don't know if you
Yeah.
have slides on costs
No, I haven't.
later. Okay. So typically the silver is about 40 to 50% more expensive than if you just go and buy the silver as an ingot from a manufacturer, and then you melt it down and you hammer it and you saw it. Now that sounds really expensive. If I'm paying 50% more, that sounds like maybe that's not the good choice of material. Well, it's not a good choice of material if you're making 1,000 of the same thing, because you can make a mold and then you can literally melt the metal and pour the metal into the mold 1,000 times. So you can use the ingot of silver and you can buy a big ingot and melt it and pour it. But if you're making one-of-a-kind pieces, all of the equipment that you need and all of the time that you need to use the traditional techniques ends up being more costly than actually the refining costs to grind it into that superfine powder. And that's one of the reasons Tanja said we don't even consider this for mass production. In fact, the jewelers that do use this as part of their production process, they use it for what they call the master. So they will make one piece. Instead of wax carving, they'll make one piece so that they can skip the wax carving, the casting into the master, and the rubber mold making, and they make their rubber mold directly from this piece. But then the mass production, when they want to make 1,000 pieces, they have to go back to the old factory method of working for that.
Which will be cheaper because of the silver being cheaper doing it that way. Yeah. Okay. So we talked about the different types that we have. So we said we had the lump type, we have the syringe type, which is very exciting to do hollow pieces as well, and intricate lightweight pieces. And then the paste type, we said we can do, we can paint it onto paper, we can paint it onto leaves, we can paint it onto objects. We can use it as a building tool, and we can also use it as a repair tool, the paste. And we also have the paper type. And so the paper type is very interesting because we can do origami. Of course, this is a Japanese product. So doing origami with it seems to be a very good idea. And with a piece of paper type like that, it's very easy to manipulate to get those interesting shapes. Other than that, you can cut the paper type into strips. You can roll it, you can bend it, you can make also some very interesting designs with the paper type. So with a bit of practice and with a bit of time, it's amazing what you can do with this product. You can even combine the products together. Now people say, but how do we combine the products? So if you're making a gold piece, then you just have to be careful to sinter it at the right temperature, right? But if you want to mix silver and gold together, because they have different melting points, you have to do the one that fires at the higher temperature first. So we would prepare this section first and fire it. And when this is completely fired at the high temperature, then we would come and we would attach the silver to it, and then we would refire it at the lower temperature, and it wouldn't affect the higher temperature one at all. And because it shrinks, it holds in the gold piece, which is already solid. So this technique in mixing different metals when you're actually working with the pure metals can be a lot more challenging than doing it in this particular way. So we're actually really excited about it, and this is another type that can be done eventually with a bit of practice, and it's called mokumegane. Now mokumegane has been around for a very, very long time. It's something that has been practiced in Japan. It has been practiced on sword hilts. The samurai had beautiful mokumegane swords. And what it is, it's a mixing of metals or a melding of metals. And these mixing or melding of metals today can be done with, say, copper and silver together. And you can do it in all kinds of shapes, in all kinds of patterns, in many, many different ways. And we just, again, we have to be careful because we have them melting at different temperatures. But there is a way where we can fire the metals together. And how do we do it? Normally we need a kiln for this, and we do it with carbon, activated carbon, so we put it in the carbon and we can fire them together very nicely. Yes, Alex, question?
Sorry. Can you go back to the paper type? We had, I can't remember if it was Belinda asking, does it tear easily? Is it very difficult to work with? Is it very fragile?
It's not difficult to work with. I probably wouldn't tear it. I would probably cut it. We cut it with a knife. So you just get a regular little, the regular cutters, a paper cutter knife, and you just cut it with a paper cutter knife. It's still soft. You could tear it if you wanted to tear it, yes.
So in my experience, I've played with it making origami, and the way they make it is they actually take a piece of very thin cloth and they infuse the cloth with the powder, and so actually it doesn't feel like paper. It doesn't feel like you can tear it. You actually do need to make a bit more of an effort to tear it. It's more, you can shape it as if it's paper, but it doesn't actually, it's not as fragile as paper.
Yeah, it's definitely not as fragile as paper. And you can also today get it in different thicknesses, which is interesting, and you can get it in square shapes, which is the origami shapes, and you can also get it in long shapes. There's a lot of people that do the paper
quilling.
The paper quilling. So if you're really good at paper quilling and you do beautiful things with paper quilling, then doing paper quilling with this and turning it into a pure piece of silver is fantastic, and you would do a great job with it. Yeah. Okay.
Great. While you move forward, Tanya,
yes.
Bella asked, what's the biggest size that you can make with this material?
We could make a statue, but the thing is, it would be very expensive. I think typically for a piece of jewelry, the biggest size I would suggest to use is about 20 grams. 20 grams already is heavy, and it's not going to be cheap, and it's heavy. So I would say that once you go beyond the 20 gram, then not a piece of jewelry to be worn, but you could certainly make bigger things if you were contemplating, a box or a trinket case or something like that. I mean, definitely that can be done, but it would not be very cheap. The different types will come in different quantities. So with the lump type, you can buy it in 5 gram, 7 gram, 10 gram, 20 gram, 50 gram. If you order it specially, you can get 100 gram as well. It's possible. Yeah.
When you say 5 grams, that 5 grams the weight of the pure silver or the
It's the original weight when it has everything in it. Yes. Everything.
The water is about 6%.
Yes. It really doesn't make
not a
huge
big element,
difference.
not a big component of the weight.
Yeah. All right. So then we come to the fact that you can practically do any design, but what's really important about this product, which is amazing, it definitely takes less time to produce a piece of jewelry than traditional metal making or metal smithing techniques. The other thing is there's much lower investment in tools and equipment. You just don't need as many tools and equipment. A lot can be done with your hands. A lot can be done with little things you have at home, toothpicks, a little scraper, even those little ear scraper things. They can work perfectly on this material. And there's a much faster learning curve, because I'm sure that everybody's worked with plasticine in school. Everybody kind of knows how to mold something. So you can very quickly do amazing things with it. And solid things, hollow things, light, delicate things. The other thing is the stone setting. There are techniques to set the stones before firing, which is much easier than having to set the stones after firing. The only limitation there is that you have to make sure that you test your stone to see whether it can take the heat or not. Because some stones do not take heat. Natural stones don't like heat, and if they have inclusions in them, that could be disastrous. The inclusions could cause the thing to explode, or it could even change color. You know, today a lot of gemstones are treated, and if you heat it up to a high temperature, that can ruin the treatment. So normally, when in doubt, do a little test on the gemstone before you put it into the high temperature, and see if it's going to be lasting before you put it. If it lasts in the high temperature, then you can put it in, and you can easily set stones in this product. Yeah. So we hope you enjoyed a little bit of information on our powder metallurgy, which is something that is very attainable. As I said, we were doing it here in Singapore. I was the first one to bring it into Singapore in 1995. We started working with it here. So we've already had about 20 or so years in experimenting with it, and absolutely love it.
We had a couple more questions,
Yes.
and maybe we have, I don't know whether we have any questions here, but one of the questions, Tanja, was from day one that said, can you make the antique effect?
Yes, absolutely. Antique effect is by what we call sulfurizing. And sulfurizing is taking a liquid which is called liver of sulfur, which is also readily available. And what we do is we heat up a bowl of water. We put a drop of the liver of sulfur. It's very strong. It smells really bad. It smells like rotten eggs. But you just put one drop into the water, and you need to heat the water. If you heat the water, it happens very well. Then you put your piece in. The piece will turn black. In fact, it goes through different colors. It'll go from gold to magenta to blue to green, and eventually it goes to black. But once it's black, when you take it out, if you sand the surface will come back up really beautifully bright and shiny, and all the little recessed areas, they stay black. So that gives us what we call the antique effect, and it works very fast, very well, very easy, and it will be very lasting. It doesn't come off. Yes.
So on that same basis, could you stop at blue and have a bluing effect?
You
like they do
could.
in watchmaking?
Yes, you could. But remember that we have sulfur in the air. And so if you're just leaving it out, eventually that blue will become less beautiful and it will turn black eventually. So the only way to keep the blue, or to keep the green, or to keep the magenta, or even the gold is lovely, is to put some coating on it on the surface. And a UV resin, like a clear UV resin or something like that, will protect it and will stop it from getting further and further along to the end, which is black. Yes.
Great, and we had one more question. What are the essential tools that I need to work with this?
Okay.
Actually, you need very little. You need
Very
maybe
little.
a gas stove at home.
Yep.
It doesn't work with an electric stove.
Yep.
So if you have an induction thing, I'm afraid you're not going to be
Yep.
able to use that.
So your hands and anything that you would use with clay. So if you have little clay, even little plastic clay devices, or a toothbrush can be used. There's so many things that you could use that you already have in your house. A fork, a knife. I mean, if you wanted to cut it, I mean, just a regular cutting knife would be great.
So a couple of other things. When you're drying, you need a hairdryer.
Yeah, a
You
hairdryer.
can leave it outside and let it dry overnight
Then you need
or for 24 hours, but that
24.
takes quite a bit of time.
Yeah.
So sometimes it's a bit easier if you've got a hairdryer and you can just sort of face the hairdryer at it for 10 minutes and let it dry more quickly.
Yes.
So drying, if you're doing the gas stove, if you're working with a gas stove at home, it's a really good idea, especially as you begin to use the material, to get a little metallic
Steel
cover that you can put on top of the piece, because if you do not dry it properly, then when you put it on the gas stove is really hot and the water is going to evaporate really fast, and if the water is inside the metal, it'll pop, and you don't want hot metal popping and flying all over the place. So if you have a little steel cover that will protect you in case you didn't dry it properly, that's not a bad idea for an initial
But there's actually a
experiment.
way to prevent that. In fact, you just don't put it directly on the flame. You put it off to one side, the rack heats up, and it gently heats the piece, because as the rack is getting hot, the piece is, and it should be already dry. Very important that it's dry before you fire it. But the rack will already make it hot slowly. And when you see that it's getting hot, and if it becomes red hot, then you can just push it over onto the flame.
Okay.
So then it'll be, the flame will be under, and then it'll really get red hot, and then you leave it for 10 minutes at the red hot. So I mean, there's a lot of ways that you don't need too much. We usually like to roll it on a slick surface, not just any surface. So I would suggest you get some baking paper. The paper you put in a baking tin, that's a nice slick surface, and it doesn't stick to it, and you can roll it, and that's usually what we use, baking paper to roll it on. Yes.
Great.
A wooden dowel to roll, if you want to, just a wooden dowel can roll it into a nice thin, you know, like you roll bread, you can use the same thing if you want. The other thing is, people ask me this all the time, but what if I use my roller, my bread roller, on my metal clay? Am I going to die from you know, that? No, you're not. It's 999 silver. It's actually edible. Not say do not eat it, but it is not dangerous if you ingest it. If you get it on your hands, it is not dangerous. We don't have to work with gloves. It is not necessary to work with gloves, right? If you get it on your skin, it's not going to hurt your skin at all. It all washes off at the end of the day. So there's nothing to worry about. As far as there's no poisons, and there is nothing, you know, bad for you with this particular product.
Great. I'm sorry, we've still got two more questions. So
Yes.
we had Claire asking what happens when you melt it down, and she had a two-part question. One of them, is it more porous, and therefore does it have air gaps that will cause a problem when you're melting it?
No, not really. If you were to overheat and your piece melts, then I would say melt it completely. Get it into a ball, because that's what metal does when you melt it. It just comes together in a ball. And then what you would do is, then you would have to use proper metal smithing techniques to roll it out in a rolling mill, and then to do whatever else you want to do with it. You know, you could saw it, you could bend it, you could form it. That's what we do with our pieces. If we make something and it turns out badly, or it looks hideous and nobody likes it, then what are you going to do? Keep a hideous piece? Not at all. The silver is good. And that's why the metal smithing actually is very useful to know, because with metal smithing techniques, you can take all of those first pieces that are not beautiful and melt them down and still make use of that metal. You can either make use of it in sheet form or in wire form, and it is perfectly good to use for that. Yeah.
Great. We had one last question. How does it differ in durability to other types of metals? So if I have a metal clay thing, is it more or less durable than something that's been cast, or something that's been
I would not
produced
say
by metal smithing?
It's that less durable than regular metals. The thing is, when metal is poured into an ingot and it's made into sheet, it goes through a rolling mill, and that rolling mill compresses it. And the compression of the metal makes the metal very hard, it makes it very strong. So we don't have that when we do the powder metallurgy. When we make cast pieces, then the metal is poured into a mold and it's not rolled out. And so I would say it's more comparable to a cast piece than it is to a hand fabricated piece. Now that being said, my first ring that I made with the powder metallurgy, I loved it, and I wore it for 17 years. Yes, 17 years I wore it, and it was 999 silver. And people say, oh, but 999 is very soft. It did have a few scratches on it after 17 years, but nothing we can't just, you know, burnish off or polish off. Nothing at all nothing that would damage it. The key is, don't make it super thin. If you make a piece really super thin, then the chances are, sure, it'll break faster. But if you have a solid item, if it's 1 millimeter or thicker, then there's not much of a chance that it's going to damage too quickly. So you do need to be concerned about the thickness of the metals. And I would say that try not to go below 1 millimeter in thickness. Yeah.
And Tanja made a comment. I'm sorry, I'm going to point at the screen, but you guys aren't seeing what I'm talking about. But if you look at some of the pieces on the screen, there are some of them that have very shiny surfaces. Typically, if I'm polishing a piece of metal using traditional factory techniques, I have the piece of metal, I've cast it, so it might be a little bit more dense than if I were making it with powdered metal. But what's going to happen is that I'm typically going to polish it with a polishing wheel or a handheld tool with a little wheel on it that's polishing, or some different sandpapers. And all of those things are just removing scratches from the surface. When you work with the metal clays, typically what you do is you burnish. So you take a steel object and you push down and you apply pressure. And that pressure is compressing the surface layers of the metal. And that's creating a more shiny surface. And that mechanical pressure is also work hardening the top surface of the metal more than you would do if you were just using a brush or a polishing wheel. So it also kind of, typically the way we work with these, where we have burnishing tools, which we don't normally use with other types of jewelry, leads to a slightly more hardened surface finish if we have a very polished finish. Great. Any other questions? We had a lot of questions tonight. Okay, fantastic. So I'd like to thank you all for joining us. And if you'd like to know a little bit more about how you can get to know more about jewelry and jewelry making, I'd like to share with you some of the courses that we have upcoming. But before I do that, you might like to know that we have some other very interesting sessions coming up in the gem jamming sequence of sessions that we're running. We have gem jamming spotlights on different gemstones if you want to know more about emeralds or rubies or diamonds or spinel. We have sessions about how you can choose the best value factors that are going to help you make a good purchase decision. And we also have sessions that talk about how jewelry is designed, how it's manufactured, how it can be assembled using fashion jewelry techniques, all of those sorts of things. So you're welcome to join us again, either online or in class for those things. Now, if you would like to know more about the courses themselves, we do have a full program on new metal technology. In fact, we have 4 different programs on new metal technologies. The first of which will be launching hopefully at the end of October. I say this because we're transitioning all of our courses into blended learning format. And so we have already finished some of the courses ready for people to start taking the blended learning elements. And this one required a lot more multiple camera angles to zoom in and give you close-ups of what we're working on. And so we're still editing this one together. But I wanted to share with you that this particular course covers the introduction to the techniques. It lets you do rings as well as pendants as well as earrings in the beginning course. It covers prong settings, so it lets you hold on to the gemstones with a setting style that you can use by setting gemstones after you've made the piece, as well as unique kinds of setting styles like the bezel setting style that lets you actually set gems in place even before the piece is finished. So you can fire the gemstones inside the piece, so you don't need to worry about how once the piece is made in metal, you don't need to worry about putting the gemstones in. They already are inside the design. Finally, it has elements on creating lightweight pieces, as well as somebody was asking about the sulfurizing or the antique technique. So it has a whole section on doing the antique techniques for these particular pieces. Our introductory course covers only silver, but then the next course covers copper.
Yes.
And the next course...
And it covers all of the different types. So the lump type, the paste type, the syringe type, they're all in there as well. Yes.
In the basic course.
In the basic course.
And in the advanced course, we do more things. We do the paper type, we do copper,
yes.
We do 950 silver, which is a different alloy.
Yep.
And then we do, as we go on, we kind of do even more
gold.
exciting things. So we do stuff with glass, where you can actually melt glass into the silver to create different colors and different shapes. Instead of having gemstones, you can have glass elements.
And we work with UV resins as well.
So lots of exciting things happening in this particular course and coming soon, so coming in October. If you're interested in getting your hands dirty immediately, our metalsmithing course has already launched in blended learning mode. That one is the traditional way of working with metals. That's the hammering, the sawing, the soldering, all of that good stuff. This needs a little bit more tools, equipment, and practice, but it is a very good combination to go with the new metals, because as Tanja said, if you make something and you don't like it, then you can't reverse it into powder. You have to melt it and then use traditional techniques to hammer it and saw it and do all of those good things. So this course is already running and is something you can look into if you're interested in the traditional techniques of metalsmithing. And if you're just interested to get to know more about the gemstone and jewelry trade, we have an awesome class called Gem and Jewelry Trade Secrets. Now this course tells you all about the gemstones that go into the pieces of jewelry, what to look for in terms of buying tips, as well as how to communicate if you're working with a customer, how to tell them what it is that you're working with, how to buy something that you can then use in a piece of jewelry that you might then go on and sell. This covers colored gemstones, diamonds, pearls, phenomenal gems, jade, organic gemstones, synthetics and imitations, all kinds of things. So it's a really comprehensive course and a really good introduction to our industry. So with that, I'd just like to summarize what we do here. All of the courses that we have are taught by practicing experts, people that are familiar with using this as in commercial ways. They're not just teachers, they're people that are commercially using their skills. And they're sharing their passion with our students in exceptional facilities in a central location. So if you're new to the place, come and have a look around before you leave so you can see the different facilities that we have. Also, the classes are small, so typically we have 6 to 8 people in a class, ensuring that we have better hands-on experiences for our students. And the courses are blended. Now this sounds like a little bit of a strange thing for a hands-on course, like a new metals technology course, because you would not imagine going and doing the course online. But in fact, it's really useful because we're able to put all of the theory, all of the things you might need to remember 6 months from now, but might have forgotten when you were in class, into videos. And also we're able to go with camera angles that you would never get if you were just standing in the classroom, looking over and seeing what's happening at the instructor's desk. So you really get to see it close up. You can play it back as many times as you like. You have access to it for as long as you need. But you also get to come into class and actually practice it with the instructor. You get to see what problems other people are having, so you get to learn from their experiences as well. And it really makes it a really good, well-rounded program. Good. So these are great options if you're interested in a career in jewelry or if you're interested in entrepreneurship. We work with a lot of local companies to help train their staff, to help train their management, and to help people get trained to go and work with those companies to be successful in the industry. And we also work with a lot of entrepreneurs, people who say, look, I don't need a job right now to go and work for somebody else. I want to be creative. I want to be able to express myself, but I want to be able to do it in a way that I can have customers and I can make money from that process. And so we have a network of professionals and entrepreneurs. We have the Creative Jewelry Studio outside, which is a great place for people to start their entrepreneurial career, and lots of exciting things for people to experiment with as they're starting their entrepreneurial path. If you're a Singaporean, you can get 50 to 70% course fee training grants. That covers the tuition fees, and you can also, on the remaining 30 to 50% of the course fees, you can actually use your Skills Future credits, if you have Skills Future credits, to offset that balance amount, which is fantastic. It means that the cost of getting started with some of these techniques is quite low thanks to Skills Future. Tanja, we had one other question maybe you can answer while you're, while you're collecting the lucky draw forms. We can hear you, we can't see you, at least on YouTube. There was somebody that asked the question, does the silver get stuck to your fingers like other kinds of clay?
Okay, yes, of course it gets stuck to your fingers. It does get stuck to your fingers. Some people like to use a little bit of oil so that it doesn't get stuck to your fingers. I'm not the type that likes to use oil on my fingers because I feel that it's not so good for the rest of the composition of the material. So I just use my fingers. But The key is the consistency. It will get sticky if you put too much water. So once you understand the consistency, then you will get less on your fingers. If you put too much water, you can get a sea of clay and it'll go on your hands everywhere. Is it wasted? It's not wasted. You could let it dry and then you can just flake it off your fingers. You can scrape it off your fingers and then you can put a drop and you can bring it back together and you can reconstitute it so that you can use it as paste after that. So there doesn't have to be any wastage. You don't have to get it all over the place as long as you're careful with the amount of water that you add to it. Thank you so much for attending. We are very happy you came tonight.
Thanks for joining us online as well.
And thank you, YouTube. Yes, everyone on YouTube. Bella and Claire and Pei Wen. Thank you. Thank you very much.
Great.